Hey, we did a quick review on graphing lines, and now we're going to go into a review again of solving a system of equations. So solving a system of equations means you have more than one equation here. And in this case, we're dealing specifically with line equations. Okay, lines. And we're only going to deal with two lines at a time. Okay, two lines at a time. And what we're going to do is we're going to say, hey, if I draw two random lines, okay, two random lines. If I just draw 1, 2. Oops, let me draw this with a different color. 1, 2. Okay, we'll say line 1 and line 2, line 1 and line 2. You notice that there's only one spot here in which they meet. Watch, I'm walking down the line, line. No one's bothering me at all. No one's bothering me at all. All of a sudden, I run into someone and I drop my lunch. So this point here is the solution. This is the point where they actually both have in common. They both have this common x and y, the same x and y, the same point for line 1 and 2. It's almost like you can say this is where the lines meet for a date. Let's say line 1 asks line 2 for a date, and they say, hey, when do you have time to meet? Well, I can meet, and let's call this 2, 1. 2, 1. 2, comma 1. Hey, I can meet at 2, comma 1. Well, do lines always have to meet? Well, we had a special type of line, a pair of lines, and these are called, let me draw it out first. What type of lines do these look like? As a reminder, these look like parallel lines. And will these lines ever meet? So parallel lines will never meet, right? They won't ever meet. So there is no solution here. While in our first example, we had one solution at 2, comma 1. 2, comma 1 was the only point in the graph where they meet. So when we're looking at normal lines, there is only one possible solution. If you use your hands and cross them in the sky, there's only one place where these hands will meet. You take two pencils, cross them, there's only one place where these can meet. If they're parallel, they would never meet. So we have so far two possibilities. They're either one solution or no solution. We actually have one more instance. And that's, what if the lines are actually the same line? If I draw my first line and my second line was actually exactly the same line. Okay, exactly the same line. Oops, let me draw it a little better. What if it was exactly the same line? Anyone here have to spend all Saturday or Sunday with your parents? Isn't your path the same as your parents' path? They're exactly the same line. The same line. Well, how many times do these guys meet? They meet an infinitely many times. Where you are, your mom is. Where your mom is, you are. And what happens is we went from one solution and no solutions to every solution being the same. Same line. So we're saying these are infinitely many solutions. Infinitely many solutions. That means all the answers, there's more than one answer. They're all an infinitely many set. Remember Jinx to infinity? So how would this look like? Let's go and look at some examples here for parallel lines first. For parallel lines, the graphs will look so similar. Y is equal to, let's use this example as 1 over 2x plus 1, and y is equal to 1 over 2x minus 3. Okay? Please take a look at what do you notice that they have the same. They have the same slope. So parallel lines, we mentioned as we did in our review yesterday, parallel lines have the same slope. Great. So these obviously have the same slope. So if I didn't draw it, I would know that they're parallel. They all start at a different y value, different y-intercept. So these lines would be parallel, and so they would never touch. Never, ever, ever touch. Over here for the same line, this actually would look like this. Y is equal to, let's write something similar, 1 over 2x plus 1. And the second equation, let's call it y2, would also be 1 over 2x plus 1. Not only would the first line and the second line have the same slope, they would have the exact same starting value. They would both have the starting value of 1. Okay, so how do we know that these are infinitely many solutions? Well, the answer is that they would look exactly the same. Well, what if they try to trick me? What if one line was y is equal to 1/2 x plus 1? That's obvious, okay? And the second one was negative 2x plus 2y equals to 2. Do these equations look the same? Not initially, right? This is line 1, let's call this line 1, and line 2. Okay, line 1 and line 2. They don't look initially the same. But let's go ahead and spend a quick minute and that's solve for y of the second equation. Let's go ahead and solve for y here of the second equation. Let's go ahead and practice that. Okay, I'll write it a little larger so we can see it. Negative 2x plus 2y equals to 2. I want us to solve for y to see if we can see it. Is it the same line? Or what is the slope in the y-intercept here? Okay, to solve for y, we're going to solve for y here. Let's get rid of our, what values do we have to get rid of to get y by itself? We get rid of the 2x, whoops, wrong color. We get rid of the 2x and the 2. So let's go ahead and do that. We get rid of the 2x first, plus 2x to both sides. We're left with 2y equals to 2x plus 2. Oops. Oh, I messed up here. I need to erase this. Folks, I messed up here. Can you erase this 2 here? Erase this 2? I messed up. I did the problem wrong. Erase this 2 here, right? That should be a 1. I fudged it. I'm sorry. Okay, and they'll give us a, yep. Okay, here we go. Sorry, fudged that one. So I got rid of the 2 from right there. So we got rid of the x to both sides, and you erase this 2 also. And then we're going to divide 2 to both sides. Y is equal to 1 over 2x plus 1. Okay, and it turns out this equation looks exactly like our other equation. So if I did draw them out, they would be exactly the same line. So when you see a problem that has 2 different lines and you're trying to figure out where do they meet, well, we should write them. I think the easiest is in slope-intercept form. And then if we're asked to graph it, we would then graph it. Okay, so let's go ahead and check out our homework today, which is IXL, and we're just really going to label it one of these 3 things. Do they meet once? Do they not meet at all? Or is it infinitely many solutions? Were they really the same equation after all? Were they really identical twins? Okay, here's our IXL homework for today. We are asked to graph 2 lines. Graph these equations. Y is equal to negative 1/2 x plus 3, and y is equal to x minus 3, okay? Then click to select the point on the graph, okay? Then how many solutions does the system of equations have? No solutions, 1 solution, or infinitely many solutions? These are 3 options. So, okay, let's go ahead and graph the first one, which is negative 1/2 x plus 3. So I'm going to click. So you can click whichever color you want down here. I'm going to click the negative 1/2 first. We see that the slope is negative 1/2 and the y-intercept is 3. So we first put a dot at 3. You guys all see I put a dot at 3. And then we climb the slope, negative 1 over 2. Negative 1 over 2. Okay, negative 1 over 2. That's my first green line. Let's go graph the second one, blue. My y-intercept here is -3. So not -3. That's not the -3 I'm talking about over here, right? That's the x-intercept. Slope-intercept gives me the y-intercept, so we're over here. It's -3, and the slope is an invisible 1. 1 over 1. Up 1, over 1. Now, looking at these two lines, do these lines meet? Do they crash into each other? Do they share one common point? And as you can see, the common point is that when x is 4, y is 1, right? Right there. Okay. So let's answer the next question. How many solutions does a system of equations have? Do these lines share one point, no points, or all points in common? They share 1 point in common. So I'm going to take one solution here. Okay. And submit. All right, well done. So let's do one more problem here. Take a look at these. -x plus 4 and -x plus 4. Oh my gosh, I can tell right now that they're exactly the same solution. I can tell that. So I'm going to go ahead and graph it anyways. So my first one, starting at y-intercept, is 4. Slope is -1 over 1. All right, done. Let's do the green line, starting at 4, going down 1 over 1. Hey, it's the same exact line. Right. You can see they actually show this double line feature here. Okay, so these points, no, these lines share all the similar points. So will we say that's no solution, that they never touch? One solution, they only touch once? Or infinitely many? Yeah, I'll say infinitely many because they keep constantly touching. Leave me alone. Like brothers and sisters fighting. Go submit. Excellent. Now, just as a reminder, if you see a problem like this, x equals 2 or y equals 2 by itself, remember they are different. X is -6, so that's fine. X is -6. X is negative. This is x here, right? So x is -6. That means all our x values are -6. See, all our x values are -6, and this gives us a vertical line. If this was y was -6, we would be, oops. If this was y was -6, whoops, where's the other point? If y was -6, we would be over here. But they told us x is -6. So that's going to be a vertical line for us. And they also told us our green line, x is also -6. Look, it's the same exact line. All right, so I'm going to jump to one that isn't as obvious. Let's go and jump to another problem. These are kind of obvious, right? This one here, we can tell that they are exactly the same. Take a look now. Why? 2x minus 3y is equal to 18, and 2x minus 3y is equal to 18. It's the same line, right? Obviously, it's the same line. But I want you guys to practice writing this in slope-intercept form. Rewriting this in slope-intercept form. So let's go ahead and rewrite this. We have 2x minus 3y equals to 18. And let's go ahead and solve for y as we practice. So we're going to get rid of the 2x and the -3. So I'm going to get rid of the 2x first as we practice. 2x minus 2x minus 2x. 3y, -3y is equal to -2x plus 18. Now we're going to divide the -3 to both sides. The -3's cancel out. Y is equal to, now -2 divided by -3 becomes a positive 2 over 3. And 18 divided by -3 is a negative. 18 divided by 3 is 6. So don't forget the negative sign. Okay? So we can graph this like we typically would. So 2 over 3x minus 6. Let's go ahead and graph it. -6, and we said 2 over 1, 2, 3. 2 over 3x minus 6. And turns out both of them are the same. Now, I want to show you guys, again, a different way of graphing it. We've talked about graphing stuff in standard form. And the other way was graphing using x and y-intercept. If something is in standard form, remember if we can find the x-intercept and y-intercept by plugging in 0. Now, this is just a review again. So let's look for the x-intercept. If I want to look for the x-intercept, we make y is equal to 0. So remember, we make y equal to 0. So 2 times what is 18? 2 times what is 18? 2 times 9. So this is our x-intercept. To solve for our y-intercept, we make y, we want to figure out what y is, so we make x 0. Next value of x is 0. What's y? So if I say 2x minus 3y equals 18, if I make x 0, remember, you can also remember I taught you guys to cover up with your hand. Negative 3 times what is positive 18? If not, you can also just divide both sides by negative 3. Y is equal to negative 6. So we have two intercepts. Our x-intercept is x is 9, and our y-intercept is y is negative 6. Let's graph these to see if it's the exact same line. Again, our x-intercept is 9, and our y-intercept, looking here, hey, our x-intercept is 9, and our y-intercept is negative 6. Hey, this was going to be the same line. So using our intercepts, we could also graph this the same way. The y-intercept is negative 6, and the x-intercept is positive 9. Okay? And this is infinitely many because they are constantly meeting with each other. All right, that's it.